Awesome, cool. All right. Good morning, everyone, and welcome to Data.Toboggan. This session, we're going to be talking about developing hybrid transactional analytical processing solutions with Azure Cosmos DB and Azure Synapse Analytics. My name is Will, and I'm a software engineer and Microsoft Data Platform MVP based in Auckland, New Zealand. So wherever you're watching in the world right now, I hope that you're staying safe. I hope that you're healthy during these challenging times. I'm really grateful to be talking to all of you today. I'm super excited to be talking about this feature that came into preview build 2020. Whenever I do a session on Cosmos DB, I'm always interested as to who in the audience has heard of Cosmos DB, who's using it in anger. Maybe they're using it for really complex production scenarios, or maybe they're just playing around with it, thinking, oh, I've heard about this product, maybe just have a tinker around with it. And I just generally do that to get an idea of who I'm talking to. But since I can't see you all physically today, I'm just going to set expectations by saying you don't need to have any experience in Cosmos DB or Azure Synapse Analytics, for that matter, to be able to follow along. It doesn't matter if you're an expert, it doesn't matter if you've just heard about it. This session is just designed to show you how you can actually build hybrid transactional analytical solutions easily using Synapse Link for Cosmos DB. Yeah, like I said, I'm a software engineer working for ASB Bank here in Auckland, New Zealand. I've been doing that for about coming up to 3 years now, and I've been living in Auckland for coming close to 10 years now. So I've been here for quite a while. I'm a Microsoft Data Platform MVP focusing on Azure Functions, Azure Cosmos DB, and .NET. I'm originally from the UK, if you haven't picked up the accent by now. So in today's session, what I'm going to do is I'll quickly cover what Azure Synapse Analytics is as a high-level overview and what Azure Cosmos DB is. Then I'll talk a little bit about what it was like to perform analytics on Cosmos DB before Synapse Link and the pain that it caused developers and analysts alike. Then I'll get to the meat of the presentation where we'll talk about Azure Synapse Link for Cosmos DB, how it works, what the Azure Cosmos DB Analytical Store is, and what benefits Synapse Link provides us, and what situations we would actually use Synapse Link. And then I'll go through a demo and show you guys how all the parts work together. As we go along, feel free to pop your questions in the Slack channel, and then at the end of the session, we'll have a Q&A session and I'll do my best to answer them after the talk. All right, so with that, let's start by introducing Azure Synapse Analytics and Cosmos DB. So performing analytics in the enterprise today requires operating on not just a massive amount of data, but also a variety of different data types. In the past, we would have to pull technologies like Spark and SQL together and then integrate them into pipelines in order to gain any insights into our data, whether that be sitting in relational data stores or data lakes. It doesn't matter where, we just have to try and pull them all together. And this was complex, and this would take time to build properly in order for us to build systems that could actually give us the intelligent insights that we need into our data. So Azure Synapse is an integrated analytics service that can help accelerate this process that scales across data warehouses and big data systems. We can use SQL and Spark in the same place and use pipelines to orchestrate our data movements. Synapse comes with a web-native studio, a studio user experience that provides a single experience for managing, monitoring, securing, and coding our data projects. Essentially, it's a unified experience that brings everything that data engineers need in one location. It also integrates well with Power BI and has built-in support for Azure ML. So Synapse is really effective for allowing developers, data engineers, data scientists to come together to build a complete solution. And then for those of you who have never heard of Azure Cosmos DB before, Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It allows us to elastically and independently scale both throughput and storage to any Azure region worldwide. You can build databases that use document data using the SQL or MongoDB APIs. You can build databases using columnar data format using the Cassandra API. Perhaps you're working with key value data, so you can use the table API to have a globally distributed table store. Or perhaps you're working with graph data, and for that we can use the Gremlin API. Cosmos DB provides us with the ability to build highly responsive and available applications worldwide, ensuring that no matter where your users are, you can bring their data as close to them as possible. You also get guaranteed low latency for both index reads and writes at the 99th percentile all around the world, which is really, really awesome for providing us with fast query times. There's multiple consistency options as well. So traditionally, we would have to choose between strong and eventual, sorry. But with Cosmos DB, we have 5 different consistency levels that are well defined that allow us to choose the consistency as required, or have a bit more granularity of consistency required for our applications. And there is no schema or index management that's managed for us. There are situations where you would worry about managing your index. But if you don't need to, it's all managed for you. And then Cosmos DB can be used in a variety of different scenarios. So you could have IoT applications reading recording device readings from IoT devices all across the world. You might be building web applications serving customers from different locations around the world. Essentially, wherever your users are and in whatever situation you need, Cosmos DB is a fantastic service that brings huge amounts of benefits for developers who want to work with a database quickly, that can scale globally quickly and easily. And then thanks to its read and write capabilities, Cosmos DB is really a first-class service when it comes to performing transactional workloads. However, when it came to performing traditional analytics on our Cosmos DB accounts, there were usually some complications that we would encounter. And at this stage, it's important to discuss the concept of throughput in Cosmos DB and how that affected our ability to perform analytics on our data. When we talk about throughput in Azure Cosmos DB, we come across this concept called request units. And request units are essentially the currency for Cosmos DB. And as you read up about request units and throughput in Cosmos DB, you'll see them referred to as RUs for short. And essentially what request units are, they abstract system resources required to perform operations against our Cosmos DB accounts. So whether you're doing reads, writes, inserts, those all cost request units. And this is across all APIs. So it doesn't really matter if you're using the SQL API, Mongo, Cassandra, whatever. All actions that you perform against our items will cost request units. Now, when it comes to setting throughput, we can either do this at the database level or the container level, depending on our requirements. We use request units to perform operations on our Cosmos DB account, and we get charged this at an hourly rate. So when you provision throughput on your container or databases, you pay for that at an hourly rate. And we can either do this setting it manually, or we can use something called auto scale, where we'll set an upper limit of where we want to scale it to, and Cosmos DB will rest at 10% of that value. And as you can imagine, this caused a little bit of limitations when it comes to traditional analytics. It would put us in a bit of a difficult spot, because in order to perform bulk analytics on our data, we would essentially be in situations where you'd have to provision extra request units just to cover this. So you can imagine if you're doing, if you're selecting across, if you're trying to select a lot of data, you'd essentially have to provision extra request units just to perform that query. And that's a waste of money and resources, and also engineering effort, because you don't want to have to go into your database, maybe write a PowerShell script to crack up the RUs every time you want to run a big query. Also in Cosmos, like I said, indexing is automatically managed for us. Depending on the size of our documents and what consistency levels we've set our Cosmos DB account to, this has an effect on our consumption. Now, we can customize our indexing policies for a variety of different strategies, along with creating composite indexes, but this is time consuming, and it's also fiddly as well. You might be in a situation where you'll have a write optimized store, and every time an item gets written to that optimized store, you might have a change feed that creates a materialized view and sticks it in another container. and you might have a bunch of queries that your users want to run. So you would be in this situation where you'd be creating all these containers with multiple change feeds, with multiple materialized views hanging about all over the place, with different indexing policies set to it. You're kind of forcefully trying to create views on your write store data, which is time consuming, and you don't really want to do that. Also, there's an idea of cross-petition queries. Now, in Cosmos DB, we scale our data, we scale our containers through this concept of petitioning. So when you create your container, you'll assign it a petition key value, and whenever you add a document to that container, you'll be petitioning on a particular property within that document. So say, for example, I've got a bunch of IoT devices and I'm recording the location of where that recording was taking place, and that's what I'm petitioning on. Now, as an analyst, you might want to run a query saying, okay, select all the devices in the world which have a damage level of high. That would be referred to in Cosmos DB as a cross-petition query. And the way that Cosmos DB works, these aren't very performance. They have high costs in terms of request units, and it's not as elegant as it would be, say, in a traditional relational store. Now, data stored in Cosmos DB containers are stored in an index row-based transactional store. And then row store format is designed to allow those fast reads and writes. But as our data set grows, performing those complex analytical queries can be expensive. So in order to do this, we would be in a situation where we might have to extract our operational data into a separate data layer, such as SQL databases or data lakes. And we could do this using the Cosmos DB change feed. So essentially what that does is just polls any activity going on in a container, and then it takes that document and you can store that somewhere else. Or we could even use Data Factory to actually export or copy that data from our Cosmos DB containers and then stick it into another data store that's more suitable for analytical workloads. But again, that can increase in complexity depending on the ever-changing needs for our users. So this is where Azure Synapse Link for Cosmos DB comes to the rescue. So essentially, it's a hybrid transactional and analytical processing capability that allows us to run near real-time analytics over our operational data in Cosmos DB. Azure Synapse Link integrates with Azure Cosmos DB and Azure Synapse Analytics really seamlessly, and I'll show that in the demo. Essentially, Azure Cosmos DB now has something called an analytical store, which is a fully isolated column-based store that enables us to perform analytics requiring no ETL jobs on our part on our operational data. And then we can use Azure Synapse Spark or SQL to run business intelligence, machine learning, or analytical workloads without impacting the performance of our transactional workloads in Cosmos DB. So a little bit more about the analytical store. So in order to solve the issue with our transactional row store data, the Cosmos DB team released the analytical store capability, which I believe is either still in preview or GA. I'm not too sure, but anyway, this analytical store addresses the complexity and latency challenges that I described earlier with our row store and ETL pipelines. Essentially, the column store can automatically sync your operational data into a separate column store, which is more suited to analytical queries. This requires no ETL on our part, no change feed, so no fiddling around with creating your own ETL jobs or messing about the change feed. This basically just syncs the data from your transactional store into your analytical store. Now, when you enable the analytical store on a Cosmos DB container, the new column store is internally created based on the operational data in your container. This is persisted separately from our transactional store for that container. There's no impact on the performance of our transactional workloads. So if we're performing complex analytical queries, we can actually do that against the analytical store, and we don't need to worry about what kind of impact that has on our transactional store. And which is great, because then you don't need to request, allocate additional request units in order to perform those queries side by side. Now, data from our transactional store is automatically synced into our analytical store within 5 minutes. So it's not real time, but it's fairly real time. Now, you may be wondering, since Cosmos DB is a NoSQL database service and doesn't worry about schema management, how can we manage this using Azure Synapse? The analytical store is optimized for analytical query performance, meaning that with the auto sync capability, Cosmos DB manages the schema inference, which includes any nested properties that you might have within your document. So when our schema changes in Azure Cosmos DB, in our transactional store, the analytical store will automatically present a unionized schema across all historical schemas within our transactional store. And with this is a new concept called the analytical time to live. Now, for some of those in the audience who may be familiar with Cosmos DB, you may know of this idea of time to live configuration setting, which essentially you can set on an item or container basis for our transactional data. Essentially what this is, when we set a time to live setting on either an item or on a setting, that's essentially a container level. Essentially, we're saying how long do we want that particular piece of data to live within our transactional store in seconds. And now this option is also available for our data sitting in the analytical store. But currently at the moment, this is just at a container level, not at an item level and container level with the transactional time to live. Inserts, updates, and deletes to operational data are synced to the analytical store irrespective of our transactional time to live setting. So essentially, we can specify how long we want to retain our data in the analytical store using the analytical time to live. And once you've enabled that, we can essentially update this value with a different value later if we need to, and we can actually set a different level to our transactional time to live as we can set different values for our analytical time to live and transactional time to live. So you may be in situations where you want your data in your transactional store to be really, really short-lived, and then you want to persist your analytical data for much longer. So you'd set that to a higher level as you would in your transactional store. And the benefits that this provides, so Azure Synapse Links allows you to directly access your Cosmos DB Analytical Store without having to create any complex ETL jobs. Any updates to your transactional data will be visible to the Analytical Store within near real time without you having to develop those ETL jobs yourself or to use the change feed. Now, ETL systems usually take a while to get the results that you want due to the complex nature of those ETL jobs. With Synapse Link, we can now analyze our operational data within near real time, which can open up some really interesting analytical scenarios for us. And like I said, there's no impact on your operational workloads. In the past, you would have to provision additional throughput on your Cosmos DB account to perform those analytical jobs or create materialized views and extra containers to accommodate for those materialized views to actually perform those analytical jobs. You don't need to implement the change feed anymore to actually store the data elsewhere. With Synapse Link, you can run analytical queries against the analytical store in Cosmos DB while leaving your transactional workloads isolated just to do their thing. So you're thinking, well, you know, that sounds great and everything, but where would we actually use this? Why would we use Synapse Link for Cosmos DB? And it's recommended for a few use cases. So if you're an existing Cosmos DB customer and you're having trouble running those analytical and BI workloads over your operational data, Synapse Link provides a more integrated analytics experience without impacting your transactional provision throughput. So for example, if you're running analytics on your BI, running analytics or BI jobs or even machine learning jobs on your operational data today, you can use Synapse Link provides a more integrated analytics experience without actually impacting your transactional stored throughput. All right, so what we're going to be doing now is I'm going to kick off into a demo. And with this demo, I've kind of prepped it in advance a little bit, but essentially I'm going to show you how you can actually link your existing Cosmos DB accounts to Azure Synapse Analytics. I'll show you how you can create a container that's using the analytical store, and I'll show you where you can actually set those different time to live values. And then I'll go into Azure Synapse Analytics, show you how you can actually link your Cosmos DB accounts into your Azure Synapse workspace, and then show you how you can actually use Spark, Synapse Spark, to actually query your data within Cosmos DB. Right, so let me just escape these slides. Okay, what I'm going to do, I'll just start right from home. Am I still sharing that screen? I don't think I am. Can you see the Azure portal?
No, we can just see demo time.
Yeah.
Okay.
Is that, yeah.
Let me stop sharing and then share my screen too again. There we go, that's better. Can you see it now?
Yeah, that is great.
Fantastic. All right, so let's go into Azure Cosmos DB. So I've got this account there. It's actually really simple to set up. So if you're an existing Cosmos DB customer or a new Cosmos DB customer, you can actually create your new Cosmos DB account, and you can actually enable the Synapse link by coming down here to features and then just turning that on. I've successfully enrolled already, so I've done that for you. But essentially, when you're creating your account, it's really just as simple as coming into the features here, tab here, and then just pressing the on button. If you're using tools such as Terraform or the Azure CLI or ARM templates to actually provision your infrastructure, I don't think this is quite available yet. I think that's potentially coming. It should be coming out sometime this year, but again, I can't confirm that. But if you're just doing it through the portal, if you're just playing around with it, this is where you go. All right. So now what I'm going to do is I'm actually going to show you how you can create a container with the analytical store enabled. So I've got one already, but what I'll do is, so I'll just use this existing one here. Won't be using this one, but essentially give it a name, analytical store. So, document type. And again, just make sure that this on checkbox is created, is clicked, sorry. Just press OK to create that. And then you should have a container that's got the analytical store enabled. And again, if you're using Terraform or if you're using ARM templates, I'm not sure if this is supported, but I wouldn't be surprised if sometime this year that it would be. All right, but here's one I've made earlier. So I've got a bunch of items that's essentially working with telemetry devices that we've captured from different IoT devices around the world. Just some test data just to show you this in action. So if we wanted to have a look at the analytical time to live settings, essentially we've got two different settings. So once we've enabled the analytical store, we're able to actually provide some, actually configure the settings. So we can turn it, if we turn it on, provide it a few seconds, that's how we would actually set that. So what you can do, this time to live is for our transactional store. I can essentially say, oh, here. I could say after 30 seconds, I want the data in my transactional store to be deleted, but in the analytical store, I want it to live for that many seconds. And that's something that we can do. So if you're looking to really just optimize the amount of data that's within your transactional store, but you need to keep it for much longer within your analytical store, that's something you can do. You can also just leave it on and not set a value at all, so it just is persisted within your analytical store forever. And then you just set this time to live value here for the data to be deleted in 30 seconds. So I'll save that. And what I'm going to do, I'm actually going to create a new container as well. Because within Azure Synapse Analytics, you can actually differentiate between different types of containers within Azure Synapse Analytics. So essentially, you might have some containers that you don't need to perform any analytics at all. So you don't need to switch on the analytical store at all. So I'll just create that. Now, what I'm going to do is I'm just going to pop into Azure Synapse Analytics. Well, let me just drag you off screen. Just re-authenticate in. So hopefully, I'm having a great time with Microsoft Authenticator today. Someone's sitting there just thinking, why is Will logging in all the time? But essentially in this demo, what I'm going to show you, or this part of the demo, what I plan to do, if my request ever comes through, is show you how you can actually connect your Cosmos DB account to your Synapse workspace. So it looks like it's happy. So within your Synapse workspace, here I've added them before, but I'll just do it again. So when we connect to a data source, we're connecting to an external data source. And at the time of speaking, you can only connect either MongoDB API accounts or SQL API accounts to your Synapse workspace. I believe if you're working with Cassandra, that's under a gated preview. So if you do have Cosmos DB accounts with the Cassandra API, reach out to the Cosmos DB team to see if they can open that for you if you want to work with Synapse Analytics. So I'll just choose a SQL API because that's what I'm working with. Just say data connection test. And here we can connect either via our connection string, or if you've got your credentials, your database connection string in Key Vault, you can also connect via that. So I'll actually connect to Velida, and then I believe it's device readings. Just test that, make sure it's okay. Connection failed. Device DB. Device DB. Test that. Cool. Once we've done that, we can create our connection. And then essentially what we'll see here, I'll just refresh you. I'll actually zoom in a little bit as well on this as well. Cool. So I've got my data connection test here. Just open that up, and now we can see all the different containers within that within our Cosmos DB account. And there's a very subtle difference here, if you can see. So here with device readings, I've got the little kind of like bar chart here underneath all the documents, and here I don't. So with the Synapse, it's a really I thought this was pretty neat, where if you have some containers that don't have the analytical store enabled for that container, you can actually differentiate via the UI, which is really, really nice. Okay, so let's hope. So let me do some, we're now in a position to query this data. So just try and get some real estate here. Cool, so I've got my Spark pool ready to go. And hopefully, if I just run that, it's starting a session. How much time do I have? Not too much, but essentially, here's one I've done earlier. So this is what I'm going to be doing. So essentially, once we've got our Cosmos DB account connected to our Synapse workspace, we can then start to work with it and query it. So here I'm just loading the data into a data frame, and then just displaying the results of that container. So this is a different container that I'm working with. So yeah, that's still working. So here I've loaded, essentially got this other container that's storing some health information about me. So this is basically how much calories I've been burning, how much I exercised, how many minutes I was sedentary, etc., etc. But what we've done here, we've essentially loaded data within our container into a Spark data frame that we can work and query with. And we can also then just do traditional data analytics work by cleaning it up, displaying it, and then once we've loaded our data into our Synapse workspace, we can then start to work and query our data without having any impact on our transactional workloads. Sweet. All right. That's the end of demo. Please don't. Yeah, I thought we would.
You've got a few minutes longer, so you can run over a little bit. Don't worry about that.
All right. Okay. Well, I think I kind of rushed it.
And there's a couple of questions as well.
Awesome. Well, I'll wrap up. So it's essentially just some things to note before I finish off. Currently, the Synapse Link is only supported for SQL and MongoDB APIs. Cassandra API accounts are under that gated preview. You can't enable the analytical store on existing containers quite yet. So if you are a Cosmos DB customer at the moment or a user, if you've got your containers all set up, you can't go in and actually enable the store on those existing containers. Unfortunately, you'd have to, while it's still in preview, you have to create a new container and then just migrate the data over if you want to have a play around with this. Once you've enabled the analytical store, after creating those containers, you can't disable it, so you can't switch back and forth. I'm not sure whether that will change in the future, but at the moment, time of speaking, you can't disable the analytical store once you've enabled it. But again, there's no impact on transactional stores in terms of RU expenditure. Currently, the analytical store is read-only, so essentially we can write back any aggregation results to our analytical store, but we can't write them to another container's we can write them to another container's transactional store, which can be used as serving layer, but we can't rewrite it back to the analytical store. Cool. So thanks for listening. Apologies for being late and being a bit rushed through this presentation. If you have any questions, we'll dive into them now. Otherwise, feel free to ping me on Twitter. Ask me any questions at any time. It is approaching 11 o'clock at night, so I might be a little late in responding to you, but please feel free to reach out to me anytime. And yeah, thanks for having me.
All right, great, thank you. I mean, we did have a couple of questions. There was one about costing and how that works, because I pinged the link from the Microsoft Docs into the chat window, but if you've got anything to share on that or things people should be careful of.
So in terms of pricing, I know you when it comes to storage, so the volume of data that's retained in the analytical store every month, including historical data, if as you've defined it through your analytical time to live value, there's a cost for that. You do pay for write operations and read operations for both analytical operations that you're performing. It is separate from the transactional store pricing. But I'd recommend, let me just find the pricing page. I recommend people check that out because there is an additional cost to it. Yeah.
And also the cost of actually reading it with Spark or SQL on demand, you're then paying. You're paying again, but you're not paying for the ETL work. The ETL stuff is all happening magically in the background, so.
You wouldn't be paying for that. You would be paying for the Spark pools that you're using. Yeah. So for this demo, I provisioned a really small Spark pool, like one of the smallest you can do, just to show you for data for the demo purposes, but there is an hourly charge to that.
All right, so we had a question from Paul Matthews saying when he created to attempt the Cosmos Link DB service using the Azure Key Vault, it tests okay, but he doesn't see it under the sort of the left-hand side. You know, when you add it in, it appears on the left-hand side as another sort of service. He didn't know whether that's a bug or whether you'd seen that as well.
I haven't seen that actually. I need to test that out. If it's a consistent issue, I'd recommend reaching out to the Cosmos DB team. They're quite responsive with stuff like this. Yeah, I haven't experienced that, so that's probably a bug.
All right, and then something that someone else asked, but I'm going to ask you now is your slides and stuff. Are they available online now, or we'll just make them available after?
I can definitely make them available. Yeah, I can definitely do that. I might post them or add them to my GitHub account. I have a GitHub account where I place most of my slides for different demonstrations. I can definitely make that link, provide that link to you guys.
All right, great. So any more questions before I let Will go? After I butchered Cosmos DB for everybody earlier, which was obviously...
That was great, Will. Thank you very much for taking the time out for us.
Oh, thanks for having me, and thanks for helping me through the Teams issues as well.
Yeah, it seems to have a few quirks, doesn't it, that we're just getting our heads around. So thanks for it's great.
I think we're all still. It's a hell of a beast, and
yeah,
even after all this time, we're still getting our heads around it.
Yeah, that's it, and various different options. So we haven't done live streaming before, so that's great. Thank you very much.
Awesome. Thanks for having me, guys.